In this video we're going to find out how to sketch derivatives in the TI-84, and it would probably be similar for newer versions. So first we turn on the power and we clear the entrances here. I have to manipulate the speed a little here, otherwise we are falling asleep. So let's see if we can work this out now. So we clear the entrances and I enter a function here. Could be anything, it could be x squared, for example. So here's my function x squared, and the TI-84 cannot per default work out your derivatives, derivative functions, but actually we can trick it to sketch it, because if we here as y2, if we choose to insert the numerical derivative, we can find that in two ways. You can find it in the math menu, or you can find it in the alpha f2 menu as insert 3 here. So here is the derivative. We want to find the derivative with respect to x, and here we want to insert the function we want to find the derivative of, and that is y1. We could of course type x squared, but if we want to change y1 later, it would be nice to have it as the variable y1, because then the derivative will change alongside with the function. So to find the y variables, you can either go to variables, or you can take the shortcut alpha f4 and choose the variable f4, y1 here. And we want to, instead of inserting a number here, you insert the variable x, so it finds the value of each x along the x-axis and sketch the graph now. So you set up your window. Maybe we want to see this from -5 to 5, and then we graph the thing. So first it sketches the original function, and then it sketches, somewhat slower though, the derivative function here. Your GDC might work a little faster than the online or the software version here. So as you can see, here's your derivative line. So it looks fairly okay. It looks like, you know, that you would expect a linear. If you need to take values from the derivative line, you can go to table, and here you can actually see the values from both the original function and the derivative function. So you can so this is a way to trick it. Obviously, you could also sketch the second derivative as y3, and this would work in exactly the same way. This time you would have to call the variable y2 instead, because we want to take the derivative of y2. So here you would go down, take y2. And we do the same here with respect to x, and graph again. And as expected, this will be a constant function in 2. And while we are waiting for the graph to sketch here, I will just say that basically this is it. Hi.